My name is Ben Hanestad, and this is my AP Physics 1 final project, where I'll look at the forces and kinematics of a bouncing basketball. Before I do the demonstration, let's run through some variables that will stay constant. This is the basketball I will be using to collect data for my project. I measured this basketball to have a weight of 610 grams, a pressure of 8 psi, and a radius of 12.05 centimeters. The surface that the ball will be bouncing on in this demonstration is just concrete in my driveway. And lastly, the ball will be falling toward the surface of the Earth, which has an acceleration due to gravity of negative 9.8 meters per second squared. In the first part of my project, I'll look at the force components of a basketball when it's in free fall and when it bounces. The bottom of the basketball will be released from a height of 1.9 meters. This is the ball dropping in real time. If we pause it in midair, we can draw a force diagram for the basketball. When the ball is in free fall, the only force acting on it is the force of gravity. Next, we can use Newton's second law equation, force equals mass times acceleration, plug in the mass of our basketball, which is 0.61 kilograms, multiply by 9.8, and we get that the force of gravity in this situation is 5.978 newtons. Next, we can pause the ball at its highest point after the bounce and draw another force diagram. Even though the ball is motionless at this instant, the magnitude of the force of gravity remains the same. In fact, the force of gravity exerted on the ball throughout the entire clip stays constant, no matter the height of the ball. Next, let's look at the kinematics of a basketball in free fall, which includes the distance fallen, the velocity, and the acceleration. We can use this kinematic equation to find the time that it takes for the ball to reach any position. For example, if we wanted to find the time that it takes for the basketball to fall 1 meter, we can plug in the known values into the equation. The final height is 0.9 meters, the initial height is 1.9 meters, the initial velocity is 0 meters per second, and the initial acceleration is negative 9.8 meters per second squared. When we solve for t, we find that it takes the ball around 0.45 seconds to fall 1 meter. We can repeat the same steps to find how long it takes the basketball to hit the ground. Plug in 0 for the final height instead. Once we solve for t, we can find that it takes the ball around 0.62 seconds to reach the ground. You can use this equation to find the time it takes for a ball or object to reach any specific position, drop from any specific height, as long as you know the acceleration and the initial velocity. Thanks for watching my AP Physics 1 final project. I hope you enjoyed it.